Dear friends, welcome to Infos. Welcome to Oil and Gas Training series. From this video onwards, we are starting a new subject, compressor, one of the important equipment using in oil and gas operations. Not only in oil and gas operation, many other areas as well. So, it's a rotating machinery. We are taking the class for compressor, part 1. So, welcome to this video, compressor. Basic classification and design overview. What are compressors? Compressors are mechanical devices that compresses gases. It is widely used in industries and has various applications. What is compressor? Look into this picture. Compressor is a mechanical machine and gas is entering to the compressor. 3 parameters is taking care of here: suction pressure, suction temperature and suction velocity. So it is compressing, and these 3 parameters is varying here in the discharge area. So discharge pressure, discharge temperature and discharge velocity. Compressor, a black box to increase gas pressure. How they are different from pump? Major difference is that compressors handle the gases and pumps handle liquids. So that is the main difference. Compressor handles gases and pump handle liquid. As gases are compressible, the compressor also reduces the volume of gas. Liquids are relatively incompressible, while some can be compressed. Compressors are fluid machines that handle gases and vapors, which are compressible, in which decrease in volume when pressure increase. That is very important. We will study that one in detail with the help of pictures in coming slide. Which increase the temperature when pressure increases, which are usually less dense than liquid. Compressors do not like liquid. What are the application side? Compressors have many everyday uses, such as in air conditioners, car, like example car, home. In our car air condition AC system, air condition system, there is compressor is there. In home air conditioner refrigeration, there is a small compressor is there. So in home as well as in industrial refrigeration also, compressors are using, from small compressors to large compressors, from different type of compressor. So gas compression for many use, gas injection, transportation, etc. We will study that one in detail. Air compressors for industrial manufacturing. Air compressors means for most of the instrumentation systems are working in compressed air. That is the driving force for that one. So instrument air compressor producing the instrument air compressed at a particular pressure and delivering to the plant. So that is also another area of application of compressor. So basic theory of compression, let us go ahead that one. Compress means to squeeze together, reduce in volume. If the 3 states of matter are looked at, it can be seen that only gas has the property which allow for compression. Solids have molecules packed tightly together in a regular structure, crystals giving them a definite shape and a fixed volume. So crystal solids cannot compress. Liquids have molecules packed less tightly in a random formation, allowing them to adopt the shape of a container and are able to flow. That means fluid properties, but liquids have almost a fixed volume. In case of gases have assembled molecules, and like liquids have similar properties, fluid properties, but virtually no fixed volume. They always occupy the whole space of a container. Liquid in a compressor can cause high power requirement, which may damage the driver or transmission components, damage to impellers and internal seals. That is why most of the cases before the compressor there is a inlet knockout drum is providing to remove maximum liquids, preventing enter to compressor casing. So before going to detail into compression, some basic laws are explaining about relation between the pressure, temperature and volume. Let us just to understand the basics of that one. Number one is Boyle's law. The basic law which relates pressure and volume in a gas is known as Boyle's law. The law is stating at a constant temperature, remember that one, constant temperature, the volume of a given mass of gas is inversely proportional to its absolute pressure. This may be written in an equation as follows: P1 V1 equal to P2 V2. So we can say suction pressure, suction volume P1 V1 and equal to P2 V2, that is suction discharge pressure and discharge volume. So just to with the help of a simple picture and diagram, we can explain this one Boyle law, relation between pressure and volume of a confined gas held at constant temperature. Remember that one, temperature is constant 300 degree and pressure is here, it is from starting from left to right, and the volume is here inside the gas. When the piston is moving down, the volume, that is compression, is taking, pressure is increasing and volume is decreasing. Corresponding graph you can see that one, when the pressure is low, volume is high. When the pressure is high, that is compression, volume is low. So this is one very good example to explaining Boyle's law. One more law is explaining a relation between temperature and pressure, and that is the Charles law. At temperature increases, the volume decreases. That is the relation here. Here it is pressure and constant. So volume and temperature is a particular parameter here. So we can see that one in next video. Look at that one. It is here. It is pressure is constant. Look at that one. Pressure is constant here. So then temperature is increasing. See, temperature increasing, volume is increasing. It's directly proportional. See, it is directly proportional here. And this is the relation between pressure, temperature and volume, directly proportional. When the volume increasing, temperature increasing. When the temperature increasing, volume increasing. Okay. So another one is Gailuka's law. If the volume of a gas held at a constant value, the pressure is proportional to temperature. That is also same, pressure and temperature is temperature increasing, pressure increasing. Pressure increasing, temperature increasing. Like that one. See, P by T is equal to constant. So three laws are explaining for ideal gas law, that is here PV is equal to nRT. This equation is derived from this Boyle's law, Charles law and combined gas law. So this is the ideal gas law. This based on this gas laws, compressor or compression principle is working, gas compression is working. So we will explain that one in our coming sections. What are the different type of compressor, what are the internals, how the compressor is installed, what are the control system on compressor, etc., etc. All details we will try to study one by one. Thank you very much for watching this video. From this video onwards, I am taking little less time. Some comments are received from various participants regarding large videos are difficult to watch and spending more time. So that's why I am ending it little bit early. So thank you for watching this video. Definitely we will come with more videos soon. Thank you.